Thanks for having me today, and I'm excited to share with you some of the more recent numbers I've been crunching on. Really, some work that began in 2015 with a survey of floatplane pilots, and just crunching that data over the years and improving the model. This is kind of the latest modeling results I'm sharing with you, and I'm also we submitted a paper. I'm thankful to a line of co-authors here presented on this title page that really helped me over the years to fine-tune this model that I'm sharing with you today. And I'm also thankful to my sponsors of this research, primarily for this latest round of modeling. The U.S. Fish and Wildlife Service has been instrumental in really enabling me to do this and share the data with you and share the modeling with you. Okay. So as many of you know, this is kind of old news to you. What we did in 2015, we did a statewide seaplane pilot survey and really asked people, where do you take your floatplane? And they went onto a map, they put a marker down, and I asked them about, okay, how many annual flights are you actually taking to that location? And that flight frequency, knowing how many flights are going from their seaplane bases where they keep their floatplanes to their destinations, really allowed us to do this latest modeling. We had really an amazing response rate, and this is really also, in my mind, a sign of awareness. Pilots seem to be very aware of aquatic invasive species and have concerns, and the survey, other parts of the survey showed this. And I think it's reflective of really high response rates that we received through our outreach that included mailing an invitation letter, and then people basically went online and filled out a survey electronically. But we also allowed people to hand in hard copies. So we had a mailer that explained them how they can provide the information to us if they didn't have an internet connection. We also did a phone follow-up, which also contributed to the good response. Then how good was the data that we got, right? And this was really a matter of looking at unfortunately, only one measured operations data, and that's Lake Hood. The FAA really counts flight operations only at Lake Hood for all of Alaska. There's no other location, and this was basically what we had to compare the data that we got based on Lake Hood, what responses we got related to Lake Hood with those operations. And it turns out it wasn't too bad. We had captured about 80% of the actual flight operations in Lake Hood. And important to say there is that 75% of the operations in Lake Hood are commercial. So any outreach from agencies trying to minimize or trying to make aware pilots, certainly an industry agency collaboration is one that I should emphasize as a good way to capture the main part of this pathway. And this is what the data looks like, and many of you have seen this map, and every time I look at it again, it's like, wow, people are really getting out with floatplanes into every single corner of Alaska. We identified over 700 floatplane destinations. To looking at the Kenai, it's looking at the whole map and then kind of honing in on the Kenai, Homer down here and the Kenai Peninsula. There are quite a few destinations, right? But the main flight frequencies here out of South Central are certainly into the Bristol Bay area and related to fishing lodges and sports fishing related floatplane activity. That is certainly one main transportation corridor, and I'm actually collaborating with the Park Service on some aspect of that part of my data. Then obviously also the Mat-Su as being a kind of an epicenter of flight activities and really high frequency flights into the Matsu from Anchorage. And then obviously these centers, right? In each region you have kind of a floatplane center. Like Fairbanks is a very obvious one with flights going mainly in the Yukon, but also into the Arctic, and is obviously you have these centers, and seaplane bases in terms of a response are the obvious target. If we keep them clean, we can really get quite a good handle on this pathway. So this map
Yeah, looks like Toby.
Hey, sorry about that.
No problem.
I'm back. Sorry about that. Apparently I have an unstable internet connection. Can you hear me?
Yes, we can hear you.
Okay, sorry. Could you hear me still talking about this slide here?
We didn't hear the transition from the floatplane map to the next slide.
Okay, so this next slide is basically a table of the flights, and it shows you that Lake Hood, obviously, as you may expect, is the most frequented, busiest floatplane base in the state, and it goes to all these many of the different regions. And I guess you all heard how I cut up the map of Alaska into different regions, right? These are the regions up here, so you could just see how Lake Hood has really the highest connectivity into these regions. Fairbanks float pond, also very high connectivity into different regions, mainly operating into, flights are being operated into the Yukon watershed. Then in Cook Inlet, there's another, this lake is another seaplane place that's relatively highly frequented. Lake Clark in Bristol Bay, the highest one, and so on. So the more remote you become, the less interconnected these seaplane bases become. This is kind of the modeling approach. It's a hierarchical model. I don't want to go into that too much, but what it allows you to do is you get basically a prediction of the median introduction rate if you're assuming that every flight is taking some fragment of let's say alluvial vegetation from a source lake into a destination. And just using that as a proxy, using the flight as a proxy for that probable pressure, you can then, with the model, look at, okay, the median probability of introduction and the uncertainty related to that estimate, right? So if you have a nation where you have only a few planes going in over a year, then it would be a fairly large uncertainty interval around that estimate, right? And you have a more narrow estimate and a narrow uncertainty band for floatplane bases. Lake Hood, down here, you can hardly see the bands. So this was mainly all of the seaplane bases or not all of them, but the main ones, and looking at, okay, so where have we observed melodia, and you can really see that some of the lakes in the Copper River, in the Copper River area, into the Cordova area, highly, the model predicts a high chance of introduction, and sure enough, those were, you know, active melodia infestations. And where we haven't found them yet are these purple ones right here. You know, we have seen them in the Big Lake, but then kind of the chance of introduction is kind of like a coin toss, right? It's a 50-50 that the model calculates. And down here are the kind of lower, obviously lower introduction probabilities, where we still have seen Elodia show up, but there we're actually believing that these may actually be aquarium dumps or other related vector related introductions could have been the cause of introduction there. So overall, the model does fairly well predicting some existing Elodia introductions. So here is just an example of a graph I will show you for the different regions, and it basically shows the water bodies in a region that the pilots identified here, and then for each water body I have basically an uncertainty interval, and then the dot here is kind of the median probability that the model predicts, predicts basically an Elodia introduction. So for this watershed, you see that about more than half of the water bodies, the model predicts and above a coin toss probability of introduction from an Elodia, but basically having a flight from an Elodia source or from a previously known Elodia source. Okay, and these over here where the model predicts like on the median probability of introduction very high or close to 1, and then petering out further down to 0. So just gives you a good sense, if this line goes further down, the more water bodies are highly likely to have potential Elodia introductions or have seen them in the past. And this is all assuming before we treat any seaplane cases. So this is just assuming, okay, we have had an Elodia infestation in Lake Hood. In this, the model still uses that known Elodia infestation in order to predict water bodies being infested, potentially Elodia being introduced into new water bodies. So for Cook Inlet, what we see, are there any questions?
Oh no, okay. I mentioned you have 2 minutes left. Okay,
so for Cook Inlet, we have about 50% of the water bodies that were identified in Cook Inlet. The model predicts a very high chance of introduction. Same in the region of Knik Arm, the Gulf, which is the Cordova area. You also have like half of the water bodies, highly likely. Kodiak, less so. The Kuskokwim also similar, only a few, and also the Yukon, only a few, and that simply be driven by the seaplane bases not yet being Elodia infested in the Fairbanks area, and similar in the Bristol Bay, and the least likely is a North Slope, where we have almost all of them clearly on the 0 chance as of right now. Now, I want to just do a what-if scenario and just expose you to this idea. And so I changed the model assumptions to actually assuming, okay, one of the Fairbanks seaplane bases is going to be infested with Elodia, just assuming that. And what would the model predict? So previously for the North Slope, we had this, as I just showed you. And then with just one of the 2 Fairbanks seaplane bases being actually invaded, if it would be invaded, see how this, the north slope could potentially be quite looking quite differently in terms of the potential risks to water bodies there. And it's similar in the Yukon, and maybe a little more dramatic actually, that currently we have kind of this prediction right here where we only have a few water bodies that are highly predicted to have potential introductions. But if Fairbanks one of the SEAPLANE bases become again, the importance is really there is clean, and with this data and with the model we can actually estimate the benefits of keeping those SEAPLANE bases clean, and we can also derive cost-benefit ratios for potential, investments if they're needed into keeping them clean. Here are the current products that we have. The data is all available online under these 3 different links. It's all archived at the data center, and if you or your agency would want to mess with the data or see for yourself or do your own modeling and your own analysis, feel free to do so. This is just part of an ongoing research, and we're now we just received funding to actually look at the entanglement probability at the rudder, and this will further kind of revise and fine-tune the model predictions I just shared with you. Anyway, thank you for your time and the opportunity to present this to you. And if you have any more questions, please feel free to email me or go through the chat if we have some more time left. Thank you.
All right, thank you, Toby. We have 3 minutes left for questions. Are there any questions at the moment? Let's see. In the chat, Catherine, said, are you able to model the results of lakes after known infestations are eradicated?
Yeah, that would certainly be another next step if we would be interested in ever quantifying the kind of benefits related to cleaning up the known infestations. That would certainly be something that we could do.
All right, the next question is from Patrick. Which treatment name shown? What is the treatment name shown there, presumably on Lake Hood?
Oh, in this last picture?
I believe so, yeah.
That was, I think Lake Hood is being treated with dicot and fluoridone.
Okay.
But I would need to refer to Dan Coleman for some specifics on that.
Visit KenaiInvasives.org to learn more.